Hi everyone, in this video we will design a column. The question is that design a short column, design a short column, design a short column to carry axial load is equal to 1200 kilonewtons. And the materials are given as M20 grade concrete and Fe 415 steel. See, this is the question they have given. First we need to determine Pu value. Pu is equal to 0.4 FCK AC plus 0.67 F5 AST. Right? Already we know this formula. This formula is available in page number 71, class 39.3. Right. Here Pu is given as 1200 it is 1200 kilonewtons into 1.5, that is 1800 kilonewtons. Pu is 1800 kilonewtons. FCK is equal to M20 grade concrete means 20 Newton per mm square. We may convert this kilonewtons into newtons, 10 cube newtons. Right? AC means area of the concrete is equal to gross area minus area of the steel. As we know, area of the steel should be in the range of 6% of gross cross-sectional area and should be greater than 0.8% of gross cross-sectional area. That's why I am assuming at least we need to use 0.8%, right? I am assuming 1% of gross cross-sectional area. Right? I am assuming 1% of gross cross-sectional area. That is equal to AS is equal to 0.01 area of gross cross-sectional AG. Right? Now AC will become AG minus 0.01 AG, that is equal to 0.99 AG. This is AC. Right? Now substitute these values in this. Fi we know, AC is equal to this one. F is equal to this one. Next, Fi we know, Fi is 415 Newton per mm square. Next, ASC we know, ASC is 0.01 AG. Right? Now substitute all these values. Formula Pu already we know. Pu means 1800 into 10 cube, that is equal to 0.4 FCK means 20 multiplied by AC is equal to 0.99 AG plus 0.67 F5 415 into AST is equal to AST or ASC. AST is equal to 0.01 Ag. Now if we solve this one, Ag is equal to 168,224.3 mm square. Now size of the column, we know the gross cross-sectional area. Now we need to decide the size of the column. If you are going with a square, then B square is equal to 168,224.3. B is equal to root of 168,224.3. B is equal to 410.2 mm. Adopt 420 by 420 mm size column. Right. Next, we need to determine ASC. ASC or AST is equal to 0.01% of Ag. Ag means 420 into 420. That is equal to 168.2 mm square. This much of steel we need to provide. That's why number of bars is equal to 168.2 divided by, I am providing let us take 20 mm dia bars, right? Approximately 6 bars we need to provide. So therefore provide 6 20 mm dia bars. You should remember one thing: minimum dia is equal to 12 mm. That you need to remember. Minimum dia is equal to 12 mm. Right? Means how much we provided here? ASC is equal to 1885 mm square. This much we provided. That means 6 into 520 square by 4 gives 1885 mm square. This much steel we provided. Right. Now coming to the lateral ties. The dia of the lateral tie should be more than 1 by 4 times of dia of the main bar. What is the dia we may use? 20 mm dia. That's why it should be greater than 5 mm and it should not be less than 6 mm. Therefore use 6 mm dia bars as lateral ties. Coming to the pitch of lateral ties. The pitch should be minimum of least lateral dimension. What is the least lateral dimension here? Least lateral dimension is, here we are using 420 by 420. Means least lateral dimension is 420 mm. Next, 16 times of longitudinal bar means 20 mm we used here. That is 320 mm. Next, This is case A, case B, case C is 300 mm. Therefore minimum spacing is, therefore provide 6 mm dia bars at 300 mm center to center. This is the pitch. Now we need to draw the figure. This is the column of size 420 mm by 420 mm. Now we are providing 6 bars. Now we are providing 6 bars. Plan it is 6 bars means here 1, 2, 3. Okay. Similarly, lateral ties. I will use green color. This is lateral ties. Okay, lateral ties. Right. The lateral ties we used are 6 mm dia at 300 mm center to center. The main reinforcement we used are the main reinforcement. What is the main reinforcement we used? It is 20 mm dia, 6 numbers of 20 mm dia. Right. This is the figure we need to show at the end.